Okay, so let's look at question one. It's really rather silly. I think the author, when they made this particular question, must not have put any reasonable constraints on the percentage of confidence. We would never want a 6.6% confidence interval. We'd want something probably at least 70% or above, because having 6% confidence would not be much confidence at all. But we'll go ahead and do it. It's going to be a really wide interval. Um, it told you what Z was. So we don't, yeah, so it did tell us what Z was already. So that makes this, that makes that rather simple. I'll do this one and then I'll also pop down to number two and then I'll show you how to enter answers for number three. Okay, so let's do this one real quick though, and let me turn on my little drawing feature. Okay, so let's notice, first of all, we're going to use the formula x bar plus and minus z of alpha over 2, and I'm not going to put that alpha over 2, and s or sigma, depending on which one we're given. We're given s here, over the square root of n. Okay, so x bar is 126 in this case. Then we'll do plus and minus, and it tells us what z is. Z is 0.08, so which it would be kind of a small value for um, and I'm assuming that's z of alpha over 2. They've put z star, so I assume that's what they mean by that, but we'll double check to make sure that this is not meant to be just z without the alpha over 2 part. We'll see. Okay, so S is 7.9, and our sample size is 477. So we'll have the square root of 477. Okay, so what we want to do first is put all of this that is after the plus minus into our calculator. So I will put that in, and normally I turn off the video while I'm doing that, so you don't have to wait for me, but unfortunately this new draw feature, and I apologize, my dog is making noises in the background. This new draw feature will go away for good if I turn that draw feature off. So I get 0.02894. All right, now let's see. What did it say to round it to? It did not say. So we'll put it at 3 decimal places. If I round this to 3 decimal places, it'd be 0.029. And what we're going to do is 126 point, or minus 0.029. And then we're going to do 126 plus 0.029. All right, so if we do that first calculation in our calculator, 126 minus 0.029, and that is going to give me, now the way it would go into this is we would put parenthesis, and that is meant to be just the round parenthesis. My drawing feature doesn't allow me to 125.97. No, my writing there is really 971. Is really bad. So it's 125.971. And then I would put a comma, and then I'd want to do the 126 plus 0.029, which will be 126.029. and then we'll close the parenthesis. Now, just in case, now I'm going to exit the drawing, which is going to make all this drawing go away for good. It does not come back. But of course, you can always stop the video to go back to it, just so we can check that that's what they meant by, and it is what they meant by the Z star. And of course, they did go to 3 decimal places, so that was just lucky, I think, that I said let's go to 3. And it's kind of standard. If they don't ask for 2, we go to 3. Okay, so let's look at 2. We'll do 2, and then I will talk about, we'll pretend that we're doing 3, so I can talk about how to put these answers in, because this is the step right before this one here. So we can actually talk about what kind of thing you would put for question 3 as we did question 2. So you measure 40 randomly selected textbook weights and find they have a mean weight of 64 ounces. Assume the population standard deviation is 5.8. Based on this, we want to construct a 90% confidence interval for the true population mean textbook weight. All right, now let's deal with our confidence interval first. The first one gave us the Z score, but here let's go ahead, and what we're going to do is 1 minus 90% as a decimal, and that is 0.10. And then once we've done that calculation, we always want to divide it by 2. And that is 0.05. Okay, now I'm going to look up 0.05 in Excel. This is a large population or large sample. We have 40, so that's bigger than 30, so we'll use our normal regular standard normal distribution. I'm going to put 0.05 in. So I am going to go to my path. Hopefully it's going really slow. And for some reason, oh, I know, I'm in the draw feature. See, that draw feature just kind of messes up everything. Okay, so I hit the little waffle and go down to Excel. And Excel will give us more accurate answers than our table, so it's often a good idea to use Excel. So we're going to go to the blank workbook. And it doesn't matter which cell I go to. I'm just going to randomly go to a cell and I'm going to type in equal norm.s.inv and I'm going to put in 0.05. And it tells me that I want to use 1.64485. Now we don't care about the negative because the plus and minus in our formula takes care of the negative. Now, if you do this in the table, you're going to notice that it's going to give you 1.645, which is a little bit less accurate than the value we get here. So I'm just going to write this one down. All right, and we'll go back to our problem. Okay, so we have a mean weight of 64, so our X bar is 64. Oops, got to put my draw feature back on. All right, so our X bar is 64. And we're going to do plus and minus. And that value we just got from Excel is the Z value. We want to use 1.64485. And when doing confidence intervals, you want to use as many decimals as you can for accuracy's sake. All right, now our standard deviation is 5.8. And then over the square root of our sample size is 40. All right, now I'm going to go ahead and put everything that's after the plus minus in my calculator. So 1.64485 times 5.8 divided by the square root of 40. And I get 1.50843. So I have 64 plus and minus 1.50843. All right, now if we were doing question number 3, notice that it has a blank and then a plus minus and then a blank. We would put, if this was the problem that we were answering in this way, we would put 64 right there and 1.50843 rounded to 2 decimal places, so 1.51 right there. And that would be how you'll answer number 3. But this one, on the other hand, wants us to go to the final step of getting the two values of the confidence interval. All right, so we're going to do 64 minus, and I'm going to do 1.51 since it says 2 decimal places. So 64 minus 1.51 ends up being 62.49. That's what would go right there. And then 64 plus 1.51 would be 65.5. And hopefully that will help you through these problems. But let me know if you need more.